Q2201, heading and ground speed are calculated using dead reckoning procedures. In flight, they are constantly monitored and corrected by A. Pilotage as observed from checkpoints. B. The wind triangle. C. The wet compass and the ground speed indicator. The correct answer is A. Heading and ground speed are calculated using dead reckoning procedures. In flight, they are constantly monitored and corrected by pilotage as observed from checkpoints. Pilotage refers to the process of visually observing checkpoints on the ground and comparing them to the planned route. By visually identifying landmarks and features, pilots can verify their position and make any necessary adjustments to their heading and ground speed. This allows them to account for any deviations from the planned track and maintain accurate navigation. Using pilotage, pilots can make real-time assessments of their position and track, taking into account factors such as wind drift, terrain features, and other visual cues. By regularly cross-checking their position with visual references, they can correct any discrepancies and ensure their navigation remains on track. While other tools and instruments, such as the wind triangle and navigation instruments like the wet compass and ground speed indicator, provide additional information for navigation, pilotage is the primary method for monitoring and correcting heading and ground speed during flight. It allows pilots to make timely adjustments and maintain accurate navigation throughout their flight. 2102. The course measured on a sectional chart by reference to a meridian is known as the A. True course. B. Magnetic course. C. True heading. The correct answer is A. The true course is the direction of an aircraft's path over the ground relative to true north. It is measured in degrees clockwise from true north. On a sectional chart, the true course is typically indicated by lines called course lines or course arrows that connect points along the planned route. To determine the true course, you would measure the angle between the meridian, north-south line, and the desired track on the sectional chart. This measurement represents the true course that the aircraft needs to follow to reach its destination. It's important to note that the true course does not account for the effects of magnetic variation or wind. To obtain the magnetic course, which considers the magnetic variation, you would need to apply the appropriate magnetic variation for the location and date to the true course. In summary, the true course is the course measured on a sectional chart by reference to a meridian, representing the direction of the aircraft's path relative to true north. 2177. If proper correction has been made for the wind, ground track will be identical with A. Drift angle. B. Course. C. Heading. The correct answer is B. The course is the intended direction of an aircraft's path over the ground, expressed in degrees relative to a reference, such as true north. It represents the desired heading to reach a specific destination. The wind has the potential to affect the actual path of the aircraft, causing it to drift off course. To compensate for the wind and maintain the desired course, pilots need to apply wind correction angles and adjust their heading accordingly. When the wind correction is properly applied, the ground track, which is the actual path of the aircraft over the ground, will align with the intended course. This means that the aircraft will be tracking along the planned course despite the influence of the wind. In summary, if proper correction has been made for the wind, the ground track will be identical to the course. This ensures that the aircraft is progressing in the intended direction and reaching the desired destination. 2103. Motion of the air affects the with which aircraft move? A. Over the Earth's surface. B. Through the air. C. In a turn. The correct answer is A. When an aircraft is flying, it interacts with the surrounding air. The motion and properties of the air, such as wind speed and direction, can have an impact on the speed and performance of the aircraft. The speed of an aircraft over the ground, also known as ground speed, is influenced by the motion of the air. If the aircraft is flying with a tailwind, meaning the wind is blowing in the same direction as the aircraft's intended path, it will experience an increase in ground speed. Conversely, flying into a headwind, where the wind opposes the aircraft's direction, will result in a decrease in ground speed. The motion of the air over the Earth's surface, particularly the presence of wind, affects the speed at which aircraft move relative to the ground. Pilots must take into account the wind conditions and make appropriate adjustments to their flight plan and airspeed to compensate for the impact of the air motion on ground speed. Therefore, motion of the air affects the speed with which aircraft move over the Earth's surface. 2104. If a flight is to be made on a course to the east, with a wind blowing from northeast, the aircraft must be headed A. Somewhat to the north of east to counteract drift. B. South of east to counteract drift. C. North to counteract torque. The correct answer is A. When a flight is planned to travel in an eastward direction, but there is a wind blowing from the northeast, it creates a crosswind component that affects the aircraft's course. To counteract the drift caused by this crosswind, the aircraft needs to be headed somewhat to the north of east. This adjustment in heading is necessary because the wind blowing from the northeast creates a force perpendicular to the desired eastward course. This force, known as crosswind, tends to push the aircraft off its intended path. By heading somewhat to the north of east, the aircraft can establish a new course that compensates for the crosswind and enables it to maintain the desired eastward track. The adjustment in heading is based on the principle of using a technique called crabbing or sideways flying. By angling the aircraft slightly into the wind, the aircraft's nose points slightly to the north of the desired eastward heading. This technique allows the aircraft to fly a track that counteracts the crosswind drift, ultimately resulting in maintaining the intended course to the east. So, in summary, when faced with a wind blowing from the northeast while flying eastward, the correct heading for the aircraft would be somewhat to the north of east. This heading adjustment helps counteract the drift caused by the crosswind and ensures the aircraft stays on course.